Okay. Yeah, so and all right, so we'll just like review what we did last time a little bit first, and then we'll go over some newer stuff today. So let me share my screen. Okay, and can you see that?
Yep.
Okay, perfect. Yeah, so last time we did like our variables, print statements, and like some math. We went over some math stuff, and then the main thing was like the if-else statements and user input. So before we like go into new stuff, did you have any questions that came up with that?
I understood it for now, but we'll see how I get it after.
Yeah, sure. So you said you already like did some programming.
I just have some MATLAB experience,
Oh
but
yeah, yeah. Um, all right. So today we'll start off with lists. So basically, lists are kind of exactly what they sound like. Sometimes they're called arrays, but they're really just a list of items. So they can be really anything. So you could have like the way that you define them would be like the name of your list. So if I'm making a list of odd numbers, I could just call it like odd numbers like that. Or and then I just set it equal to square brackets, and then inside I just define each of the items and separate them with commas. So I could just do like 1, 3, 5, 9. So those are all just like separate items in a list. So this list would be 5 items long technically. And you can also do like different data types. So if I wanted to make like a list of animals or something, I could do like strings. So like dog, cat, and then you could just like keep going on as long as you want. So that's kind of how you define lists. Like you'll notice that right now, all of these are one data type, like each of these lists, but you can make, in Python specifically, you can make lists with different data types in them. There's not really any specific reason you would want to do that, but like if I just make a list called list 1, I could make it like 1 hello, just like random stuff inside it, and it would let me do that. A lot of languages don't let you do that, but in Python, for some reason, if you wanted to do that, you could. So basically, the way that list indexing works is a little bit it's like a little bit weird. It's different than MATLAB. So if we're trying to get like the very first thing in our list, we would do like, so let's say I'm trying to print dog from my animals list. Then I would do like my normal print statement, and then you do the name of your list, and then square brackets, and then in here is where you would put like the position of your item in your list. But instead of 1, it starts at 0. So if I do 0 and I run this, oh, forgot about this, prints out dog. I'm gonna comment out like the top part of my code just so it doesn't let me just comment out the input part. Okay. So yeah, it prints out dog. And then, so if I wanted to print out cat, I would do 1, and mouse would be 2. And if I try to do 3, it's gonna give me an error because it says that it's out of range because there's nothing at position 3. So does that make sense?
Yeah, yep.
Right.
And so I know Python's different from MATLAB. So is this kind of like the starting point of like making a matrix in MATLAB?
Yeah, almost. It's a little, usually you can do something like this in Python using like what's called 2D arrays, which are like basically matrices. But Python also has like a package that you can import that's called Numpy. I don't know if you've heard of that one, but it lets you do a lot of the same things that you do in MATLAB without like having to use like weird Python syntax. So it's like more similar to MATLAB, but it's better for matrices. But yeah, this is kind of like a start to like how you would do matrices in Python. Yeah, the main difference, if like I learned Python before MATLAB, so I was like MATLAB confused me because it started at 1 with like matrices, like your very first position is at 1. But it's just like good to remember for most programming languages besides MATLAB, they usually start like lists start at 0. And also another thing that we can do is like if we have a list of some unknown length, so like pretend we didn't know how long this one was. If we want like the very last thing in our list, we could do like print list 1, and then instead of putting a number here, we can just do like the length of the list minus 1, because that'll be our last position. So like len as our length function, and then outside of, it's kind of hard to see here, but like all of that is inside the square brackets that are like the index of the item. So I have to fix this first. Yeah. So it prints out the last item in my list. And you can also do like sections of your list. So like if I wanted to print out from my animals, I just wanted to print out like the first 2, like dog and cat, then I can do animals. And then in my index here, I put, it's like 2 numbers. So the first one is like the starting point. So the starting point would be like 0. And then the second one is our end plus 1. So it like excludes the number that you put in. So like if I put in 2 here, then it's going to go 0, 1. Yeah, it's going to go 0, 1, and then exclude position 2, which is mouse. Does that make sense?
Yeah, yeah.
So when I print it out, it just prints out dog, cat. Yeah, and then you can also change the values of lists. So like right now, if I just try to print out animals just as it is, it just prints out like dog, cat, mouse. I can also say like animals 0 equals horse. And then if I print out animals again, it'll like update it like that. And there's also ways to like add stuff to your list. So if I do like the name of my list dot append, so that's going to add something to the very end of your list, and it like pops up here and it says that it takes in an object. So I would just specify like what I'm adding to the end of my list. So let's say I wanted to add dog back in, and now if I print it out, we have dog at the end. And lists are usually not in order, but sometimes, like a lot of the time, they're like used as if they're in order. So like we can also add in things at specific indices. So that's like if you use insert. So it pops up here where it says like index and object. So you say like where you want to put it, and then it'll like insert it and then push everything one over, and then like whatever object you want. So if I want to put something in the second spot, I would say 1 and then I can think of. Yeah, and then it's going to insert it like in our second spot and then push everything else over. So those are like the main 2 ways to add something to your list. But you can also remove stuff from your list. So one way is just to do remove. So animals.remove, and then you say what you want to remove. And it'll just find the first time. So like if you have multiple of like, if I had multiple tigers in my list, it would only remove the very first one. But if you have a bunch of unique things in your list, then it'll just remove that one. And then the other way to do it, which is used more often, is pop. So there's 2 different ways to use pop. So like if I just do pop and I don't put anything inside there, it's going to remove the very last item. So now dog is gone. And I can also do like, if I want to specifically remove horse, then I can do animals.pop 0. And that'll remove that for me. So do you have any questions about lists right now, or like what you can do with them?
No, not really at the moment. It makes sense.
All right. Yeah, so trying to think. Okay, yeah. So basically lists just they're kind of like linear almost, like there's only just like one value per position. But we also have something called dictionaries. And I'll just kind of go over it really quickly because they're pretty useful. And basically what it is, it's like, I mean, you can think of it like a dictionary, where like dictionaries, you look up a word and there's a corresponding definition. So in code, dictionaries are like, you have a key that goes to a value. So examples could be like, if you have a bunch of names, then they correspond to like birthdays, or if you have a bunch of, I'm trying to think of examples, like cars, and they correspond to like, I don't know, like things about that car, like the year, model, whatever. So the key and value, they can have any data type. So like the name and birthday one, that could be a name, so that's just a string, and then the birthday could be also a string, or you could do name and age, so it's like a string and an integer, or you could even do like a name and a list. So like that would kind of look like, so you have a string to like a list, and your list would have things like it could be like age, birthday, occupation, things like that. Because like earlier, like I mentioned, you can have lists that have different data types in them. So you could do something like that to hold a bunch of information, and then you basically have a bunch of those like name and entries, like corresponding entries in them. So dictionaries are used a lot to like hold a lot of information all in like a single like data structure, basically. So like really simply how to create like a dictionary. You can kind of just feel like, what should I call it? I'll just call it, you're technically not supposed to call it dict, so I'll just call it like dict, wait, equals, oh, so we can do like, kind of go off the animals example and just do like their, what's it called? Animal kingdom class thing. So we could have like dog as our key, and then the value, the corresponding value to dog would be mammal. And you could technically do this all in one line, but it just kind of looks nicer when you like do enters in between, just so people can read your code and you can read it too. Do snake, reptile, and then let's do like one more, like different ones. Frog is amphibian. And these are basically like, so everything on the left side is a key, and then everything on the right is a value. So if I want to like get what a dog, like a dog is, then I could do print and then the name of my dictionary, and then we have our square brackets almost like we do for lists, except instead of saying the like position that it's in, we can just say like our key value, and it should print out mammal like that. Yeah, and then if you want to add, like, so if I printed out this entire dictionary right now, then it would just look like that. So let's say I wanted to like add something to it, I could just define a new key just by doing this maybe, so like cat, and then I just set it to whatever value I want it to be, like with an equal sign. And then now if I print this out again, it'll add cat to the end. So like dictionaries are used, I mean, usually to store like a lot of information. So like if you have information that's like this, like a key and a value, and a lot of classes that use Python or like dictionary or have projects with like dictionaries in general, I've seen it used a lot for like keeping track of like word count or something like that. So like, for example, I had a project once that was like reading through a bunch of documents, and you get to see how many times each word was mentioned in total. So like every time, like you just basically, every time you get a new word, you add a new dictionary value, and then you set it, like you add one to its count, if that makes sense. And then you have like this giant dictionary of just like words and how many times they appear in these documents. Yeah, so far, any questions about dictionaries?
No, not really. It makes sense. Yeah.
Okay, cool. Yeah, this is kind of like very basic level, but it's just like something to know that like it exists and it's pretty useful. Okay, so like the next big thing is loops. So there's a few different types. Mainly there's 3 different ones that I use a lot in coding or just Python too. So the first one is kind of related to lists, and it's like a for each loop. So what it does is it goes through each item in a list. So like like I have my animals. I only have 2 in here, but let's say let me just comment out the part where I it's like a little bit longer. So right now when I print out my list, it just kind of prints it out in a straight line like this. But if I wanted to print it out like more like a list, so there's like an enter in between every single one, I could use a loop for that. So if I do like for I in animals, and I is basically your each, so it's like for each item in animals, and I can be anything you want. You could even call it like for animal in animals, if that makes more sense to you. But usually you just use like some letter, like I, J, K. So for I in animals, if I just print I basically represents each item in my list. So now when I run this, it'll print out each one separately. So every time it like goes through the loop, it like prints out the first one, then it goes to the next one. So I equals tiger, then it prints out tiger, then I equals cat, and so on. Does that make sense?
Do you mind repeating that again, please?
Yeah, so like basically every time it goes through this loop, so it goes through this loop however many times, like, wait, let me start that over. This loop repeats for however long this like list is. So animals is right here. That's the last time I printed it out. So it was 5 items long. So this loop is going to repeat 5 times. Except like this is usually used this when you don't know how much you want to repeat. So you just know that like all I know is I want to print out every item in animals like on my console here. So in my first loop, I is going to be equal to the very first item. So horse, and then it's going to print it out inside my loop. And once it's done with everything inside the loop, which is just this print statement, it's going to repeat. So now I goes to the next item, which is tiger. And then it prints that out. And then it goes to the next one. And it does that for the whole list. Does that?
Yeah, that makes a little bit more sense. Yeah. So it goes through each item once per loop, is what you're saying.
Yeah. So yeah, for each, it's basically, that's what it's saying. So it's like for each item in animals, that's what I means. It's going to do like whatever's in here. So for each item in animals, it's going to print out that item. Yeah.
Yeah, it makes sense. Yeah. Thank you.
Also, just like a quick thing, if you just do like a print and then empty parentheses, like there's a few different ways to do it, but it'll print like an enter basically. So I'm just going to do that because it's getting a little bit cluttered on the side. Yeah. All right. So these are there's also like normal for loops, which use instead of like going through, you can still use them to go through lists, but it's more like when you know how many times you want to do something. So that's when you use for loops. So for loop is, it looks like, or I'll type it out first and then I'll explain it more. So instead of I, I'll use J this time. So I would do for J in range 10. So this range 10 basically creates a list. And it's a list starting, it starts at 0, and then it just goes like all the way to 10, but it excludes 10. So it goes from 0 to 9. But since it starts at 0, it like there's 10 items in this list, right? So basically it's pretty similar to this. So we're still doing like almost like a for each, except we're creating a list like in our loop. So it's going to do it, like here we said that we know that it's going to do it 5 times because we only have 5 items in this list. And here we know it's going to do it 10 times because this range creates a list of 10 items, which all happen, they just start at, like, they're just numbers that start from 0 to 9. Does that so far make sense?
Yeah.
Like, yeah, okay. So j basically equals 0, and then when it loops around again, then it's going to equal 1, and then 2, and so on. So if I just do print j, it's going to just print out like what my list is, like this list that I just typed here. So it just goes from 0 to 9. But you can use this however you want. So like, let's say I just wanted to print out something 10 times. So I just wanted to print out like hello 10 times. Then I could use it like that. I don't even have to use j as like a variable inside my loop. Does that make sense?
Yeah. Yep.
And you can also use this with lists. If you're using like here we're saying like I is equal to each item, right? So we can make it so that I is equal to the index instead. So that would kind of look like for k in range, and then in here we would just put the length of our list. So like since the length is going to be equal to 5, so it's going to make a list that looks like, look like 0, 1, 2, 3, 3. And this is like pretty nice because remember how our list like items start at 0, like the index starts at 0. So if I just say print animals k, because now k is our index instead of our item, then it's going to do like print animals 0, which is the very first thing, and then print animals 1, which is the second thing, and then so on. So yeah, now it prints out everything right there. So did the for, like these 2 different ways, or I guess it's 3 different ways to use for loops, did that make sense? Or do you want me to re-explain anything?
Yeah, that makes sense. So just to kind of recap, the IJK, that's just like a stand-in for like your list.
Yeah, basically. So it's like it represents each item in whatever list we're putting here. So it can really be called anything. So like if I wanted to call like this one, for example, since it's like or actually I could just call it item, that makes more sense. So like since this variable here represents each item in my list, I could just call it item instead for like clarity. If that, like, I actually usually do that just because it makes more sense to me when I read code. But if you type it out like that, then it makes it more clear like what you're actually printing out. So it's printing out each item in my list called animals. You just have to make sure that it's like the same, it's called the same thing inside your loop too.
Yeah, that makes sense. Yeah.
All right, so there's one more type of loop called a while loop. And while loops are usually when you don't really know how many times you're going to do something. I mean, you can use it for that, but it's usually when something becomes true. So it's like based on a condition. So I'm trying to think of an example. Oh, okay. So like we did the user input thing, right? Let me just go grab that. So one way you could use the while loop is like if we're using user input and they type in the wrong thing, it'll just keep prompting them for the password. So we define our password here, and then we could just, here, I'll get rid of the if else part. So this is the part where we ask for input. If we just say like while entered is not equal to password, it's just gonna keep asking for input, basically. Oh yeah, because entered isn't defined before, so I'm just gonna set it to like 0 for now, so it doesn't give me an error. So basically, if I, oh, and then the other thing I have to do is make this an integer. So, or actually, let me just make this a string here. Okay, so now when I run this, it says like, what's the password? If I just type in 1, 2, 3, 4, it stops running my code. But if I type in like 1, 2, 3, so it didn't match up with like my password. So it's just gonna like keep asking me until I type in the right one, and then it'll, oh, yeah, and then it'll stop. It'll like break out of the loop. Does that make sense? Like,
Yeah, yep.
yeah, so while loops are usually on conditions. You can also use it for like, for a certain number of like times like you're doing something. So if you have like a variable like n equals 0, and then you do while n is less than 10 and 10, the only thing is like you have to make, like you have to keep adding to n every single time. So and then if you do like n plus equals 1, so every time this loops, it's going to print n, add 1 to n, and then loop, and eventually it'll reach 10 and it'll stop looping. Yeah. So it goes to 9, adds 1, 10, so then when it checks this condition, it just breaks out of the loop.
So if you don't add 1, it's just gonna loop forever.
Yeah, so like if I commented that out, it, yeah, it might actually just crash, I don't know. Well, basically it would just print out 0 like forever. So that's like, that's the thing with the while loops to be careful with, is just that it can put you in an infinite loop. Yeah, which will like usually crash whatever you're doing, or sometimes like depending on what you're doing, it'll make it like really, really hard for you to just even stop your program from running. So it's good to check that.
Yeah, I've had that problem with MATLAB.
Yeah, it's happened to me. It's MATLAB makes it really hard to break out of it. It's annoying.
Yeah.
But yeah, it's definitely like good to check that. Yeah, so that's kind of it for loops. The last thing I wanted to go over today was like functions. So, okay, so any questions on like anything we've done so far? Because functions is kind of like the last, I guess, bigger concept.
Yeah, the loops make sense so far.
Okay, cool. All right. So you've probably heard of like functions before in MATLAB. Basically, like you define your function first, and then you can call it. So you can, like, it's usually use them for repetitive code so that you don't have to like type it out every single time. You can just type it out once, define it, and then you can call it wherever you'd like. So like a really, really, really simple function would just be like, what to say, greeting. Well, so basically we started off by saying def, which means that we're defining it, and then we say the name of our function. So we'll call it greeting. And then we put parentheses after, and then a colon. So the parentheses are, they hold any parameters or input into our function. So for this one, we'll just say that there's no input, so we'll leave it empty. And then in here, I'll just print hi. So basically, this is just a function that prints out hi. And if I run this, nothing will happen on its own, but I have to like call my function. So to do that, you just put the function name, parentheses, and then if there's any parameters, they would go in here. So now when I run it, it prints it out once. And I could just, every time I wanted to print out hi for some reason, I could just copy and paste this, even though this is only a one-line function, but it's just like a quick example of how to define a function.
So every time like you define a function or a new function, at the end of the stuff you define, you have to call it, right?
Yeah, so it doesn't necessarily have to be at the end of it. It's just like wherever you need it. So sometimes like what I like to do is define all my functions in a separate file so that it's not like in here and then I just call them in my main file. Like I think in MATLAB, the way it is like you define all your functions at the bottom, right? Usually. And then you call them inside your code.
Yeah.
Yeah, so it's kind of like that. But yeah, you usually do it after you define it. So this is the definition, and then the other one is the call. So yeah, it won't do anything until you call it. Yeah, so that's like a really simple function. You probably wouldn't really even need a function for that because you could just copy and paste that line. But another like simple example with parameters or like input would be like just adding two numbers together. So let's just say I have two numbers, A and B. So those are going to be my parameters. And I'm just going to have it print A plus B. If I wanted to, I don't know, make it like this for some reason, I can do sum equals A plus B and then do print sum. And then to call it, I do add. And then here's like where I actually use my input. So I put like the actual two numbers I want to add together. So if I do 3 and 10, it's going to input those in for A and B, and now it prints out 13. Does it make sense how the input works? Or like the parameters?
Yeah, so like you add in the numbers that you want to input at the end when you're going to call it.
Yeah, exactly. Yeah, so that's where you put the actual values for what you want to do. And now I can call this as many times as I want, and it'll do it differently each time. Yeah, and then it prints out the value. So something that is really like common with functions is instead of using a print, we use something called a return. Have you like done that before? So you just like say return and then what the value you're returning.
No, I've never seen that before.
So return is like return is kind of better than print because it actually gives a value back. So instead of just printing it to the console, it lets you store the value it's returning. So right now when I run this, so I type in this password. So it doesn't actually print anything for these two function calls that I did. But now I can like let's just say for the first one I just do I'll just call it sum1 equals this like this function call. So since this has a return statement, it's gonna basically set my variable sum1 to whatever this function returns. And again, like when I run it, it's like not going to print anything, but like later in my code, let's say I wanted to print sum1 or use it for something like later. Now when I do it, now it prints it out like later on. Does that make sense?
Just a question.
Yeah.
So in the function you call A plus B sum, but then on line 177 you called it sum1. So like the fact that it's different? It doesn't really matter?
Yeah, so whatever's inside the, like, variables that are inside the function don't, you can't access them outside. Like if I do a, like, oops, like print a here, I think I defined like some random variable called a like way earlier on. So it's gonna, yeah, it prints out that instead. It doesn't print out like what's in here. So those variables are only inside the function. Yeah. And then like, let's say I made this one sum2, oops, sum2, and if I wanted like later to do like sum1 times sum2, for example. So like now I have both of these values, like 13 and whatever this one was, saved in variables. Now I can just multiply them together like later on, maybe in my code. And then, yeah, and then I get that value. So returns just basically let you store information. And you can still print it out too if you want to. It's just like a little bit different. So instead of doing the print around this, I could just do print sum1. And then it would print it out like that. So does the return make sense?
Yeah. So another question. For when you define adding 3 plus 10, you call it
Yeah.
sum1. So like, does the name have to include sum? Because in the
Oh no, yeah, it can be whatever you want. I just made it that because I was just using this. Yeah, no, it can be like if it's actually if it has like some kind of meaning, for example, then you would probably want to name it after that. Like if it's like a different kind of function. But yeah, I just called it sum1 and 2 because it's just like adding numbers together.
Okay. Yeah.
Yeah, the variables can like all the variables can be called whatever you want. Technically, it's just usually good coding practice just to have it be like what they actually are, just so other people can read your code.
Yeah, it makes sense.
Um, yeah, and like you could do like a lot of functions for like they can have anything in them. Like these are both obviously really simple ones. They just this one just prints something, this one just adds two numbers together. But uh, let's say I'm trying to find something that we did before. Oh, okay. So like a good one is like the Pythagorean theorem, which is like a little bit longer. You probably wouldn't want to type that out every single time you have to use it. So if I just call it like Pythagorean theorem, and you get two values. So like let's just say A and B, and we just have to type out like the equation. So if we're trying to find C, for example, so C equals, I know like last time you asked about square root, so that would be math dot square root. And then it would be like a squared plus b squared. So squared is like two two asterisks and then 2 plus b two asterisks and 2, and then you can use parentheses around here, but it's like the same. For the most part, the order of operations for like math stuff is the same as what it is with like normal math. So you don't really need anything like parentheses here, but if you want, you can add extra ones. And then we'll just return C. So like if we have one triangle that's 3 and 4, it's like a really simple one, then we could find that using this. This is also like a simpler function, but it might be something that you use more just because it's kind of like a pain to type this equation out like multiple times. And then it returns the value like 5. Does Does that make sense? Or any more questions on functions or what you can do with them?
Yeah, it makes a lot more sense now.
Yeah, you can add like a lot more stuff like let's say we had another parameter that was like called right, and it's either like true or false. And we can just say like, oops, that's not what I meant to do. Like if right equals false, then return. Usually like you keep the data type the exact same for like your return types if you have multiple like different things that you can return. So like here someone might return 0 instead of returning like printing something out, like saying like, oh, this isn't a right triangle. So like if I return 0, then like if I do true here, but then if I call it, or okay, wait, let me just change it here. So this isn't really the best example, but like it would return 0, or we could just say like return not a right triangle, something like that. Yeah, I don't know. This isn't really the best example, but there's different ways to like, you can add a lot more into your functions. So it's good to like put longer pieces of code into functions. And it kind of just helps organize it too. But yeah, so that's kind of all I had for today. Did you want to look at this any longer, or are you good?
Yeah, I'm good. Yeah.
Okay, yeah, I'll also be sharing it out later. So yeah, let me let's see. Yeah, so next time we'll do like object-oriented programming, which I don't know if you've heard of that, but that's more like Java stuff and like C, C++. So you don't use it a lot in Python, but Python does have it as like a thing. So like for more advanced programming, it's like good to start with it in Python. And then we'll kind of go over like some practice problems so that you can kind of like apply all these like coding concepts to like actual problems, and it'll make more sense. But yeah, I'm gonna stop recording right now.